Good evening, my dear JEE 2026 aspirants, class 12th and global students. Today, we are on to the next topic of the chapter of electrostatics, Gauss law, and we are going to talk everything about the concept of electric field, what is its significance, electric field due to multiple bodies, and also electric field lines and their properties. All right, so let's begin this class. Amazing physics class for all of you with your Captain Shreyas Sir. Yep, your Captain Shreyas Sir is here. And I have been training kids for more than 13 years now, and yet another year, but with the same enthusiasm and the same energy, guys. And every year, it's always something new, it's always something refreshing, and it is very unique. And every set of students always bring that extra X factor with them and those new challenges which you have to conquer. So 2026 is your year, right? So let's begin. I hope you have marked your attendance and also, like the video and subscribe to the Vedantu JEE English channel. Please do that. And yes, please remember that our batches in all the offline centers are running in full speed, and new batches are being started for all the JEE and the NEET aspirants. So this year we had amazing results in JEE Advanced, all India rank 15, 92, KCT toppers, ISI toppers, Olympiad toppers, cracking many examinations apart from the JEE mains and JEE Advanced. So with this gives us that extra boost of energy and that confidence that we are going to do even better next year. So now it's your turn with the personal attention, with digital classrooms, with all the high-tech facilities and the best teachers, with full doubt facility and academic mentorship available at so many cities across the country, be it Maharashtra, Andhra, Tamil Nadu, Kerala, or Punjab, right? So make sure you are giving the IVSAT examination and availing the full scholarship for your offline admission. Yes, the links are there in the description box of this particular live video as you are watching it. Yeah, yeah, it is there. Plus, smash this like button. It's there over here. Explore our offline centers. And by the way, our newest center over here is in Bangalore. Yeah, where is it? Bangalore. Yes, the Bangalore center is the newest center. It's in JP Nagar. Okay, cool. So, welcome everyone. Sir, please start coaching institute in Tripura. I know there is not much coaching centers. We'll definitely start. Hi Hema, hi Resanti. Welcome Prashanti. Welcome. Isala Cup Namdu. Yes, if you are Isala Cup Namdu, then please make sure you are in one of the Bangalore offline centers too. And last line, we had conducted the first class of our lecture 1 of electrostatics. We did electrostatic charges and Coulomb's force, and a lot of you answered the questions. Very good. Aruneshwar, funny memes from Kerala. Thank you for all the love. Durga, very good. Ambika, very good. Pradesh, very good. Unhan, Stephen, football, Ibas, and Vignesh, and Thala 7, Kartika, Mohammed, and so many of you. Very good. Keep it up. So every session you are going to get, the homework. Make sure you are solving that homework and posting the answers in the comment section. Okay. 8 o'clock is 12th standard. 6 o'clock is 11th standard class. So let's begin with the concept of electric field. Yeah. Jack, why don't you leave that comment? I will definitely answer your question. Will I cover JEE 2026 backlogs? Yes, if you have backlogs, then watch the 11th standard classes at 6 o'clock. Okay, creative, is that fine? All right, so let's begin then. See, we had seen before that if you have a charge Q and another charge Q2 separated by some distance R, then there is some kind of a force of either attraction or repulsion depending on whether they are like or unlike. And that Coulomb's force F is given by your constant K, or you can also use 1 by 4 pi epsilon naught, where epsilon naught is permittivity, or in SI units 9 into 10 to the power 9. and then you can put Q1, Q2, the whole thing divided by Q1, Q2, whole thing divided by R square. This was your Coulomb's force formula between two charges. But I have a very genuine question. See, when you have some charges over here, when you have some charges here, and you bring a charge, let's say Q, then there is a force acting on it. There is a force on that Q charge due to due to the system of charges. Due to the system of charges, these are some charges. But my question is more basic, more elementary. How the hell did this small q even understand that I need to experience an electric force? How did it even know that there are some charges around? It's like you enter a forest, you can't see anything, it's completely dark, but if you are a charged body, you will experience a force. So it's not that you have to be conscious, you have to be aware. Even if you are sleeping, even if you are unconscious, unaware of things, still, just because of the mere fact that you are a charged body, if you are in the vicinity of some other charge, you experience a force. How did we even understand what is the direction of the force? How did we understand, what should be the magnitude of the force? I know we are going very, questioning even the deepest of the deepest things over here. So imagine a situation when these charges are still there, but you have nothing here. There is nothing here. There is absolutely, so we'll just duplicate this. Yeah, there is absolutely nothing around, nothing in the vicinity, nothing in the vicinity. Even when there is nothing, absolutely, no air molecule, no liquid, no solid, nothing absolutely, I feel there must be something which tells, in case a charge arrives here, that hey, listen, there is a charge over here. It's like the trees in the forest are whispering to you, hey, listen, there is a charge here, be aware. Oh, you go to the next tree, that next tree tells, hey, you are closer. It's like somebody is telling you some kind of information. And that information around these charges is called as the electric field. It's sensed in the form of electric field. So even when there is nothing around it, even when there is nothing around it, there is an aura. Like you have used this word aura, in Gen Z slang, aura 999, zero aura, aura plus one, like that. So there is an aura of the charges, of the charges. There is an aura of the charges. And this aura is also in the form of an information. This is also about that information, as in how strong are these charges, which direction will they push or pull you, all these things. So it gives you a sense of the magnitude and the direction in case you bring in a charge. So suddenly when you bring the charge, suddenly the charge knows, oh, I need to be pushed here, oh, this much is the force. So that information was present. That is said to be the field. There is a there is a there is a field of those charges. There is a field of those charges around it. Around it. Okay, there is a field of those charges around it. Now, do you understand the concept of electric field, my dear students? So, electric field can even be present in isolation. See, for force to act, you need two charges. If there is only one charge, it has nobody to apply the force on. Make sense? But the moment the second charge comes, zoop, there is a force. But before the second charge came, what was this singular charge doing? It was creating its own aura. Hey, you know what? I'm this great. I'm a positive charge. Hey, you know what? I'm this value. If you come here, I will apply a force. So that is what is basically electric field. Everyone, absolutely clear? Yeah. How electricity produces magnetic property, nobody knows. It just produces. You call it as magnetism. We'll come to that later on in the next chapter, but for now, it's okay. So how do you measure this field? See, one thing is for clear. You cannot have any other charge around it because the field is this, guys. This charge is producing the field. So to measure the field, I need a charge. That's the paradox, or that's the irony of it, I would say. I mean, to see if there is electric field or not, what do I need to do? I will place a charge and I will say, oh, there is a force. Oh, there is electric field. Yes, correct. You are right. That's what you will say. The problem is that charge in itself will produce its own electric field. So that is why what we do to see if there is a field or not, we take such a small charge which is tending to zero, which will not produce its own field, and this is just for testing purposes. And when we create a test, it should be a standard test. It's not like I give a difficult paper to one person and an easy paper to other person. It should be a standard. And for that sake, we use a positive charge for testing, because somebody will say, sir, I use negative charge, I got this direction. Somebody else will say, sir, I use neutral charge. I mean, you will get no force only. Somebody will say, sir, I use positive charge. You will get force in some other direction. So to maintain a balance and standard and uniformity, we said we'll always use positive charge to test, but that positive charge should be extremely, extremely small so that that will not create its own field. And what if that charge might affect, what if this charge starts affecting this charge? Maybe this starts moving. Then that becomes our headache. So this charge will not affect these charges in any manner. So it is as if you are not feeling only somebody has come. Getting my point? Yeah, everybody? So like when your parents are cooking food, and let's say you want to test whether the food is good or not even before it is finally cooked. So you just take a small bite or a small, pinch of it, and you just put it on your tongue. It is salty. Oh, it is spicy. Oh, it is sweet. And you understand. It's not like you take one mug full of that dish and you pour it in your mouth. Oh, it is salty. You have finished half the dish. Now, what will I do, man? So that is why you will take a pinch of it. So that's why for testing purposes, you take a small test charge. So now, in order to test all of this, I will use a very small test positive charge, and that charge will experience some kind of a force on it, which I will call it F. That charge, because it is small, I can also say limit that Q tends to 0. Limit of that charge, where that charge tends to 0. Limit of that particular charge where that charge tends to 0. Then the field, then the electric field is defined as this property E bar, which is the force per unit positive test charge. Force per unit positive test charge. Per means division, so it will be basically you will have force over here, and per unit test positive charge, that means Q, but do not forget that limit. So limit Q tends to 0. This is the exact formula for electric field. Limit Q tends to 0, force by Q, okay, where Q is extremely small. Don't worry, this answer will not be infinite, okay, it will be a finite value only. Having said this, you can also see it is also a vector quantity. It is a vector quantity. And when I say it is a vector quantity, the direction, very, very important, the direction, how will the direction be? Think about it. if it is a positive charge and you are around it and you are here, if you bring a positive test charge over here, that positive will be repelled by it. So the force will be in this direction. So whatever is the direction of the force is the direction of the electric field. But if you had a negative charge over here, just imagine if you had a negative charge over here and you're standing at this point to measure the field, you bring in a positive charge, that positive will be attracted by this negative. So the field will be directed this way. So the field's direction depends on the direction of the force acting on the test charge. The direction of the force on the positive test charge. So whatever is the force direction, if it is repulsive or attractive, same is the direction of the electric field. Is this absolutely clear, my dear students? Next thing, what is the SI unit? What is the SI unit of electric field? As you can clearly see, this is Newton, this is Coulomb. So the obvious unit in SI will be newtons per coulomb. But later on, you will see that we can also derive a new unit, which is nothing but volt per meter. Volt per meter is also the same as Newton per coulomb. Okay, both are perfectly fine. This is absolutely clear, my dear students. Continuity and differentiability, Jagdish, actually a maths topic. So Ninja ma'am will be teaching it to you in your 12th standard syllabus. Okay, when differentiation begins, I think shortly it will begin, the calculus part. Okay, so differentiability, continuity, everything will be a part of your math syllabus. We assume in physics that you would have studied there. Okay, well, Nitika, very good. Hema, Rupesh, Netish, Gozhar, Jagdish, everyone absolutely clear about this. Perfect. Now that you have understood the physical significance and the electric field, so let's find the electric field. Let's say due, due to a point charge. Due to a point charge. Let's do this. Electric field due to a point charge. So say for example, this is our point charge Q and we are at some distance R from it, and I need to figure out what is the electric field at this location. So by definition, I know electric field is nothing but I need to take the force and then take the charge and divide it and limit that charge tending towards 0. So what is my next step? I will actually think of that positive test charge over here and I will see what will be the force acting on it. The force acting on it is given by Coulomb constant Q into small q divided by R square. This small q is exactly this q, and but I have to also divide by this small q over here. So limit q tends to 0. So kqqq divided by R square is that force. What happens is that this q and this q just get cancelled and I don't have really anything to take limit of. See, when you have limit of x tends to 0 of some y, then it's just going to be y. Making sense? So when there is no x in the equation, why will you worry about substituting x? So there is nothing to take limit of. Hence, the answer for this particular expression will be nothing but, what is it? K Q divided by R square. I was just interested in the magnitude over here. So I'll just put E. Direction wise, I know which direction will it be. So it's not good to put F bar over here, just F. So KQ by R square is the magnitude of the electric field. K is Coulomb constant, Q is the charge because of which you are finding the field, R is the distance. Obviously, it should not depend on the test charge because test charge was meant for testing. How can the test charge be there in the final answer? Think logically. Okay, what you are used for testing should not be there in the final measurement. I mean, or that would not make any sense. So that's why Q anyways got cancelled. You can also see that the graph for this, looks something like this. If you plot electric field versus R, which is basically the distance which is basically the distance, you can see it is inversely proportional to the square of the distance. So the graph would look something like this. Electric field is inversely proportional to the square of the distance. As you go far away, the field becomes negligible. When you come very close, the field becomes infinitely very strong. It becomes very, very powerful when you're close by. So I can say it becomes very, very strong over here and it becomes very, very weak over here. As simple as that. Okay. These are some important things which you can note. Clear? Oh, late for the class, Vasuki, no issues, but make sure that you set the alarms, subscribe to the channel. Yeah? Okay, very good. Very good. All right. 1 second, guys. Not my chats. Why is it looking small again? Second, guys. Okay. So I think now it is looking good. Okay, great. So this is one formula. Maybe we can also see a question on that. Example, just a simple example. Can you find the field due to an electron at a distance at a distance of 4 nanometers? At a distance of 4 nanometers, what should be the electric field due to an electron? So electron obviously negatively charged, so negative E, and you are at a distance of 4 nano. Nano is 10 to the power minus 9 meters. And here I'm trying to figure out what kind of electric field will be there, magnitude wise. Obviously, direction wise, it will be towards the electron. So the magnitude of the electric field is simply given by kq by r square. Let's use this formula. K into q divided by r square. All is magnitude. K is 9 into 10 to the power 9. Charge is 1.6, 10 to the power minus 19. Whole thing divided by r square. R is 4 into 10 to the power minus 9, the whole square. So let's see what we can do. Maybe we can write it as 9 into 10 to the power 9. Let's write this as the number 16 into 10 to the power minus 20. The whole thing divided by 4 square is 16 and minus 9 will make it minus 18 when you square it. 16 will cancel. So 9 into this is minus 20 plus 9. So minus, or we can just keep 10 to the power 9 as it is. Minus 18 and minus 20 will cancel and it will become minus 2 on the top. So this will become 9 into 10 to the power 7, but this will be Newton per Coulomb. So this is the magnitude of the electric field, 9 into 10 to the power 7. Yep, everyone, absolutely. Okay, great, great. So this is how you can simply find the electric field. Now, let's choose something else. Electric field due to a ring on its axis. This is also a very important formula. It looks something like this. Observe. You have a ring. You have a ring like this. It has its own radius. It has its own radius. There is a charge q on the ring. And you are located somewhere on the axis. This is the axis of the ring. That is the perpendicular to the plane of the ring. And at this point, you want to find what is the electric field. You want to find what is the value of this electric field. That is the question. Okay. Electric field on the axis of a charged ring. So in order to do that, you have to use some addition and summation and all of that. So let's understand what it is. See guys, there are many charges on the ring. There are many charges on the ring. Like there is a charge here, here, everywhere. So each charge will give an electric field. So if you just consider maybe a charge over here, which is, let's say, dq, that charge at this particular location, just let's forget this for now, at this particular location. By the way, what will this distance be? Because it is hypotenuse, it will be root of r square plus x square, will create a small electric field like this. Why small? Because it is a dq charge. That dE electric field will be Coulomb constant into dq divided by the distance square. Distance is the root of r square plus x square, the whole square. So basically it is k dq divided by r square plus x square. That is the small electric field which is created by it. This electric field will have now two components. One component here and another component like this. Another component like this. If I just mark this particular angle over here as theta, even this particular angle will be called as theta. So therefore, this component will be dE cos theta, and this component will be basically dE sin theta. Why did I split it into components? There is a simple reason for it. And the reason is as follows. If you consider one more dq charge over here, diametrically opposite, diametrically opposite in nature, then that also at this point will give rise to another small electric field like this. So this electric field and this electric field, each of them will have horizontal components and also vertical components or perpendicular components. What do you think will happen when both the charges give the combined effect over here? I feel their cos components dE cos theta will add up, whereas this and this components, the d sin theta components, d sin theta will basically cancel out. Yes, it will just end up cancelling out. And what will happen? This is live, Sarvesh. Yes, this is live. Sir, is there any trick to remember the fields for each shape? No, Hema. Once you get used to solving problems, it will become very clear in your head. As simple as that. Okay. So don't have to struggle in memorizing it. You just have to use those formulas in many problems, basic substitution, use it 100 times, 200 times in many questions. It will automatically get stuck in your head. This means if you take any two diametrical opposite points, their cos components will add, sin components will get cancelled. So this means for all such diametrically opposite pairs of charges, the d sin theta will get cancelled. So the perpendicular dE sin theta will end up cancelling. Only the axial, component, which is dE cos theta, will add to give the net electric field. So every charge will have d cos theta, d cos theta, d cos theta, d cos theta due to all these charges. So all of these d cos thetas only will give to the net electric field. So can I then clearly say that the net electric field will be the integration of dE cos theta, out of which the value of dE is this, So it is K into dq, whole thing divided by r square plus x square. Okay, it is all there in the integral symbol. Okay, and what is cos theta? Cos theta, you can see from here, adjacent side by hypotenuse. So adjacent side by hypotenuse, guys, adjacent side is basically how much? It is nothing but x by hypotenuse, which is nothing but r square plus x square raised to 1 by 2. Most of the things will come outside, like k will come outside, even this x will come outside, and even these people are nothing but r square plus x square. 1 plus half is 3 by 2. 1 power and half power is 3 by 2. Okay, and what remains inside is only integration of dq. What happens when you integrate dq, guys? dq, 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 if you add for the entire ring, you will get the total charge. Remember, x was a constant, it was not a variable, so it is not a complex integral. So therefore, this will just become k. You will have r square plus x square raised to 3 by 2. You will also have this number x. Integration of dq is basically that total charge q. Is basically that total charge q. Okay, and cos theta over here is adjacent side by hypotenuse. So that's how I get the formula. Hence, the electric field magnitude is given by your Coulomb constant into charge into x, whole thing divided by r square plus x square raised to 3 by 2. Please remember this formula. Derivation also important from JEE advanced perspective. Sometimes some difficult question of mains might use a concept, not exactly the derivation, might use a concept from this. You never know. Okay. Sarvesh, it's completely up to you. Both are good books. Okay. Sengeja and DC Pandey, but I prefer DC Pandey. Okay, I prefer DC Pandey. All right. Now, this was one formula. There is another formula which you can also remember. You can also remember this, where imagine, oh, by the way, what will happen if you are at the center? A special case, a special case, a special case. If you are at the center, if you are at the center, just think about it. If you are at the center, the value of x will be 0. If x is 0, forget anything else. Electric field will also be 0. Makes sense, because from everywhere, the fields will act and they will end up cancelling out each other. The fields will act and they will just end up cancelling out each other. So, if you have a complete circle and you are at the center, the field will cancel. But imagine this, you don't have a complete circle, rather you have arc of a circle. You have an charged arc, let's say something like this. You have a charged arc like this, okay, and this has some radius, maybe like this, okay, and what is given to you is linear charge density, linear charge density, which is basically how much charge is there per unit length. The symbol for that is lambda, and the unit of it is coulomb per meter, because it is charge per length. So coulomb per meter is the unit of it. How much charge is there per meter of that arc? It's like an arc. Okay, it's an arc. So what happens is the net electric field which comes exactly on the angle bisector, comes on the angle bisector. Because it is positive, it will be repulsive. If it was negative, it will be exactly opposite. Magnitude will still be the same. So if the total angle, if that total angle is theta, then this electric field is given by 2k lambda divided by 2k lambda divided by, here you have r, and then what else you have? How many of you remember this? Thank you, Sarvesh. DC Pandey, if you have, very good. I'm so glad, Sarvesh, you're loving the lecture. Yes, what is the answer that you will get? There is something, some trigonometric formula. Yes, you have sine of what is it? Theta by 2. Sine of theta by 2. That is the answer. This is something which you should remember. This also comes via integration. We are not doing that integration, but just remember it. Okay. These are the most important formulas, guys. Let me show you an application of this so that you guys appreciate this. So that you guys appreciate this formulas. So the question is as follows. If a charge of Q is on a semicircular arc of radius r, find the field at the center. Find the electric field at the center. That is the question. So let's draw that arc over here. So this is that arc. It's a semicircle. So we just need half of that arc. Okay. The radius of that is basically r. So the radius is r and there is a charge of q distributed on it. So I just know that if I draw the angle bisector will be exactly at 90 degrees. The electric field will be exactly in that direction. So I know the electric field will be like this. So magnitude wise, I just know the formula which we have just seen, 2k lambda by r sine theta by 2. So 2k lambda by r sine theta by 2. But we need to start substituting the values. K value is 1 by 4 pi epsilon naught. 1 by r will be as it is. What is lambda and what is theta? Both these things are very, very crucial in solving the question. Okay, what is lambda and what is theta? Theta is very obvious actually. As you can see, this whole thing is basically theta. This whole thing is basically theta. So theta is basically pi radian. Theta is basically pi radian. So I can just put pi over here. Is that obvious now, everyone? Okay. All right. Now what to do next? Is there any way to clear my doubts with you other than the live classes unknown? Be a part of the Sigma batch. I am there very regularly over there. You have PNJ sir who himself is an IITN. Plus you have the inbuilt class teacher. Plus I am there for mentorship and guidance, in the Sigma batch. So if you are a part of the Sigma batch, you get my guidance. Okay. Right. Now the careful part you should be is for that lambda. See, my dear students, the charge is distributed over here. Okay, be careful. The charge is distributed. So if you ask me what is lambda, it will be the charge by the length. But what is that length? Length is the semicircle's length, which is just pi r. Oh, so lambda is technically q by pi r only. Q by pi r only. Okay, so I had to substitute that. Now I will get the answer. Okay, so we have 2 and 4 cancelling out. We just have q over here. So I'll just put it over here. 2 and 4 cancelling out. 2 over here. Next thing, sine of 90 degrees, sine of pi by 2 is just 1. So keep that also in mind. So on the numerator side, only q is there. We also have 2. Pi into pi is pi square. Epsilon naught is there once. And r into r is basically r square. So this is the electric field. Strangely, we have pi square over here. Okay, everyone, can you see that? Pi square is also there. Yep. Is that absolutely clear, Sarvesh? I think you missed that pi. 4 is also not there. And lambda has to be substituted. Yeah, you cannot leave it in terms of lambda because in the question they gave q. So q has to be written down as, lambda has to be written down as q by pi r, which is the length of that semicircle. length of that semicircle. Yeah. Sir, is exam idea book enough for boards? Ayo, what is this? I'm not sure. All right. Next, can you quickly find out this answer and put it as homework in the comments? Okay, I'm going to give you this question as homework. Find the field due to a charged ring of 10 microcoulomb, radius is 2 millimeter at a at a distance of 2 millimeter from the center on the axis. That is the question. Okay, so think about it. This is there as your homework question, my dear students. Find what is that particular electric field on the axis. So this is your homework question. Okay, so this is your homework question. Homework question. I want all of you to put the answer in the comments. Next lecture, I'll be seeing it. The lecture is not over. This is just the question that I want you to solve as homework. Okay. Everybody should be able to do it. It's not that difficult because we have already discussed this particular formula. By the way, there could also be a question on how the electric field changes with the distance graphically. If the question is like this, how does the electric field change with the distance? The answer to that, guys, can you guess it? At this point, it is 0. But when you reach very, very far also, you are not going to get any electric field. So the graph starts from 0, becomes maximum, and it tends towards 0. Yes, it starts from 0, becomes maximum, and tends towards 0. By the way, if you are worried about, sir, where is the field going to be maximum? Where is the field going to be maximum? The answer to that is at a distance of r by root 2. So at a distance of r by root 2, the field becomes maximum. As simple as that. Okay. Is that absolutely clear, everyone? So this graph also can come in JEE Mains or in JEE Advanced. In JEE Mains also, this kind of graph has come. Where is the field maximum, or which of the following is the correct graph of the electric field? Why it starts from 0? You can see x is equal to 0, E is equal to 0. Also, if you take another case, just think about it. If you are very, very far away, then as x tends to infinity, even the electric field tends to be 0, because you're so far, there is hardly any effect of it. So that's why at infinity also it tends to 0. So it reaches the maximum and again comes back. So that is one unique thing about the graph over there. Now moving ahead, imagine you have some electric field over here, and in that you place some charge. Then there will be a force acting on it. There will be a force acting on it. That force obviously will be how much ever the charge is multiplied by how much ever the field is. And one special thing about it is that if I take two special cases, if I put a positive charge versus if I put a negative charge. If I put a positive charge, then the force is in the direction of the field. Okay, very, very important. Then the force, electric force, is in the direction of the field. If I put a negative charge, the force is opposite to the direction of the field. Very, very important, guys. How the force behaves versus the field for a positive and a negative charge. Okay, absolutely very, very important. Next important thing, you can also find the acceleration because of that, because this using Newton's law, using Newton's law of motion, since F is equal to ma, therefore acceleration is force by mass, therefore acceleration will be nothing but the force is q into E. So you put q over here and then E over here, that's it. So q into E divided by m. So that gives me the acceleration of the charged particle because of that field. Acceleration of that charged particle because of that field. Very, very important. Okay, clear? Yes, Jani, you can definitely attend the classes from here also, no doubt. Yeah, it's completely up to you. Now that you have understood it till here, let me go ahead and where is that? Yes, this is that question. This is that question. Let's see if we can do this. There is a charged particle which enters a point A and exits from point B. Its speed makes an angle alpha and beta at the entry and the exit points. Then what is the ratio of the kinetic energies given alpha and beta are 60 and 30 degrees? The electric field is in this direction. A charged particle enters like this and exits like that. So the charged particle has some alpha equal to 60 degrees. So maybe it goes like that and goes like this. Okay, so it is going like that. So the question is, what is the ratio of the kinetic energies at B and A? Important thing, electric field is in this direction. Electric field is in this direction. This is the direction of the electric field. Okay, fair enough. Now let me think, guys. See, if there is electric field, there will be electric force. If there is electric force, there will be acceleration. And we know that acceleration, we just figured it out. Acceleration, which is force by mass, force is charge into field like this. So acceleration will be in the direction, as you can see, acceleration will be in the direction of the field, which means which direction? In the y direction. So can I then say ax is 0 but ay is non-zero? So there is no component of the acceleration in the x, but there is only y component. That's all. This is crucial for solving the question. This concept is also there in projectile motion, where acceleration due to gravity is vertical, but there is no horizontal component. And over there, what do you do? Because there is no horizontal component, the horizontal velocity will never change. So that means very clearly that the velocity in the x direction should remain constant. Which means if initial velocity, okay, is u, then the component of it, I mean, you can check it out right over here. See, guys, if this is alpha, it is very obvious that this will be also alpha. This is u. The x component will be u sine alpha. And over here, when it comes out with some velocity v, this is beta. The horizontal component will be v sine beta. So can I say that our u sine alpha will be equal to v sine beta? Everyone with me on this? And what is sine alpha? Sine alpha means sine 60. So u sine 60 will be v sine beta. Beta is basically 30 degrees. Therefore, sine 60, which is root 3 by 2, and sine 30, which is just half, 2 cancels. Therefore, I will get u root 3 is equal to v. U root 3 is equal to v because 2 has cancelled. Now let me come to the final part, which is kinetic energy of B by kinetic energy of A. It is half m v square by half m u square. Half m cancels. So I'm left by v by u whole square. But wait a minute. What is v? V is nothing but u root 3. V is nothing but u root 3. We just saw it over here. So just put that and square it. U cancels. So I just have root 3 square, which is 3:1. Hence, the kinetic energy of B is to kinetic energy of A is in the ratio of 3:1. 3:1 is the answer. Is this absolutely clear, my dear students? Everyone? Very, very good question. Yeah, very, very good question on concept of projectile motion being used, where if there is no acceleration in the x direction, velocity will not change. So use that. So immediately you get the relationship between the velocities. Once you get, you can easily find the ratio of the kinetic energies. Another good question coming up on your screen. A charged oil drop is suspended in a field so that it neither falls, neither rises. So the charge on the drop will be how much? Okay. So there is a charge and there is that mass on it, and it neither rises, neither falls, meaning the weight of it, which will be basically m into g, should be balanced by some other force. Who is there? Electric force. So it should be Q into E. So if they balance, then only it will be at rest. And it is mentioned that a charged oil drop is suspended, that it neither falls nor it rises. So it is at rest. So 100% QE should be equal to M into G. What do we want to find? The question is finding the charge. So Q will be equal to M into G divided by E. Is the mass given to me? I think so. Take the mass of the charge as 9.9 into 10 to the power negative 15. G value you can take it as 10. Field value you can take it as 3 into 10 to the power 4, which is given over here. Okay. 9.9 divided by 3 is obviously 3.3. This is minus 15, so it will become minus 14. And this 4 will go on the top as minus 4. So this will become 3.3 into 10 to the power minus 18 coulomb. So 3.3 into 10 to the power minus 18 coulomb, which is C option. Very good. Yep. Yes, Paidi. That is C. Very good, Nitika. Perfect. Yes, Vignesh. 3 option. Clear, everyone? Absolutely. Okay. Very nice. Very nice. Keep it up. Keep it up, guys. So these are some of the questions which are directly on the electric field, but there could be some questions which is dependent also on the electric field due to multiple charges. Due to multiple charges, which we have already kind of discussed when we discussed the formula for the ring, and it makes sense also. Say you have charge Q1, you have charge Q2, and like that there are multiple charges here and there, and the last charge I call it as Qn. And you consider a point somewhere here, and you want to find the net field at that point. So obviously what you will do, due to this charge, due to this charge, due to that charge, due to another charge, like that, you will find their electric fields. Maybe this guy contributes this much, this guy maybe contributes this much, maybe this guy contributes this much. So, there will be different electric fields, E1, E2, E3, En. So, if I have to find the net field, the net field is the superposition of all individual fields by vector addition. Very, very important, because they are all vectors. So you need to consider the direction also. So if you take E1 vector plus E2 vector like that till En vector, what you are going to get is the net electric field. Simple. Vector addition has to be done because there are multiple charges. This is called superpositioning principle when there are multiple charges. This is exactly what we have done when we did the question of the ring, if you think about it carefully. Every charge gave some electric field. We have taken the total effect, and we took the total effect. What we did was integration. What is integration at the end of the day? It is summation, adding up. So that's all. It's a vector quantity. Yep. So we have to consider the direction. Because we consider a direction only, one component got cancelled and the other did not, right? If it was not a vector, we would have just integrated d. But since we integrated d cos or d sine, that means it was supposed to be taken as vector quantity. All right, so let's take up an example. Okay, like this over here. This is a very common example. Two charges are there which are placed at 0 and L respectively. Find a point on the x-axis where the net field due to both of them will be 0. There will be a point where the net field will be 0 due to both of them. So let's see what those charges are. This is one very common kind of question which is asked in JEE. So plus 8q is there, and then you have minus 2q over here, and the separation between them is given to be how much? It is L. One is at 0, one is at L. So this is L. So somewhere the field will be 0. Somewhere the field will be 0. How do I know where the field is 0? See guys, if I choose a point here, this positive charge will give an electric field like this. And this negative charge will also give an electric field in the same direction. So which means they both will add. Will they cancel? No, right? So the field will add and never be 0. And it can never be 0 in this region. This will also give this way. This will also give this way only. It is negative charge. So it will attract. If you maybe take somewhere over here, or maybe let's say over here, then what is the situation? Okay, let's try to think. So if I'm somewhere over here, this will give a very strong electric field because you are closer. So it will give a very strong electric field like this. Okay, it will be E positive due to the positive charge. But due to the negative charge, it should be attractive, but it will be very small because this distance is very far away. So E negative will be small. This will be small. This will be large. So can they cancel? No, they can't cancel out each other. They can't cancel out each other because you are closer to the big charge and far away from the small charge. So it does not balance out. But maybe when you are here, what happens? You are far away from the big charge. So because the charge is big, the field should be bigger. But because you are far away, again it comes back, it normalizes. So maybe the field due to the positive charge might be able to balance the field due to the negative charge. The negative charge is small, but you are closer. You are closer to the smaller charge. Closer to the smaller charge. This is the only place where it may balance. It may balance out each other. They can cancel out each other. Do you guys understand which region, how to decide? Everyone? Everyone? Kanish, it's a very vague question. You're asking, can I go for bioscience and bioengineering? Obviously, if you have interest, it's a good enough thing, but it is a new branch in IIT Guwahati, so keep that in mind. So we don't have any reference point whether it is going to have great placements or not, but with the IIT tag, it should be good. But if you don't have any other options and you don't want to take a drop and your interest is bioscience and bioengineering, only then go for it. But if you have some other opportunity, try something else because it's a very first time it is being done. So it's not risky, but why unnecessarily take a chance? I mean, you will be the first batch which will be experimented. Okay. So going ahead with the problem, guys. So let's take that point somewhere over here. Let's assume that this distance is x. So due to the positive charge, the electric field will be like this, and the value will be k into the charge, which is 8q, the whole thing divided by this whole distance, which is how much? L plus x, the whole square. Similarly, due to the negative charge, the field will be exactly opposite. It will be k into 2q magnitude wise divided by just the x square. Both of them should cancel out each other at this particular point because the net field is 0. Both of them should cancel out. So let's just cancel them out. K, K, Q, Q, 2 and 8 cancels becomes 4. So what is left over here is 1 by x square is 4 by L plus x the whole square. Take roots because it is looking very obvious. We can take roots. It's perfect squares. So 1 by x is 2 by L plus x. Now the best thing to do is cross multiply. So L plus x will be 2x. So therefore L will be 2x minus x. So 2x minus x is x. So x is basically L. So x is basically L. Just check it out. Did we miss out on something? 8q minus 2q. Yeah, perfect. L plus x. Okay. Whole square, and this is x square. This was 4. This was 2, 2x, L plus x. Did we miss out on something? Oh, the coordinate. The coordinate was asked. Yeah, the coordinate was asked. Yeah, x is L. That is perfectly fine. So, see, this is 8q. This is minus 2q. The x coordinate of this guy is 0. The x coordinate of this guy is L. So if you further go at a distance L, the x coordinate will be 2L. So we are talking about the x coordinates. So the coordinate will be 2L. So I think B should be the answer. Yes, it is B answer. So it was not just the distance from the charge. This x was technically just the distance from the minus 2q charge. So if you check the coordinates, this is the answer because this will be L and even this will be L. So L plus L is 2L. Is that okay? Perfect. Yeah. Why x not between the charges? Spidey, I just told you, if it is between the charges, the positive charge will give a field here. The negative charge will also give an attractive field here. So both these fields will not cancel, they will add. So when they add, how can the field be 0? So that is why the point where you find neutral, basically 0 field, it will not be between those two charges in this situation. But maybe this was positive, or this was negative, then it will be in between both of them. Because if this is positive, they will both cancel somewhere in between, not this side or that side. So both charges have to be like in that case. Okay? Right. Right. I would suggest IIT BHU Metallurgical rather than BS in chemistry because you would obviously go for a BTech degree than a Bachelor of Science degree. BTech degree has higher value and IIT BHU is good. Okay. Although you might lose out on the chance of switching the branch in IIT Kanpur, but still it's a big risk. Kanpur is a top IIT and top students are there. You should not take such a big risk. Okay, fair enough. Now, let's say we have another question, beautiful question over here. Infinite number of charges are there, each equal to q, are placed along the x-axis at 1, 2, 4, 8 and so on and so forth. Find the field at x equals to 0 due to the charges if there are infinite number of charges. Wow, such a beautiful, beautiful question, isn't it? So this is your number line. Let's say this is your x equals to 0 point, and at x equals to 1, then 2, then 4, then 8, you are placing the same charge. Which charge? Q, 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 like that. So the distances are at 1, 2, 4, 8, and so on and so forth, powers of 2. I can sense some series already. Yep, at these distances. So, what will be the electric field at origin? What will be the electric field at origin? That will be the net field. So, that will be the electric field due to the charge at 1 plus the charge at 2 plus the charge at 4 plus the charge at 8 and so on and so forth. There will be infinite number of terms. E1 will be K into Q divided by 1 square. then kq divided by distance is 2 square. Similarly, kq divided by 4 square, and so on and so forth. And this will keep on continuing. What is common is kq, and what we have over here is 1 by 1 square plus 1 by 2 square plus 1 by 4 square plus 1 by 8 square, and so on and so forth. What is this, guys? Is this some kind of geometric series that you can see? Is this some kind of geometric series that you can see? Come on, my dear students. I want you to think. Have you learned series and progressions? Have you learned series and progressions? Yes or no? Tell me. So does this look like one of that? Does this look like one of that? Yes or no? If it looks like one of it, what is it? Yeah, basically 2 raised to n is there. Yes, and you're also squaring it, and in GP, and a converging GP. Very good. So this is basically 1 by 1, or 1 by 1 plus 1 by 4 plus 1 by 16 plus 1 by 64, and so on and so forth, where the first term is a, which is 1, and the ratio is 1 by 4. Ratio is basically 1 by 4. So kq, so here basically our a is 1, common ratio is 1 by 4. It is in geometric progression. Sum till infinity is a divided by 1 minus r. So use that formula. A is nothing but 1 divided by 1 minus r. R is basically 1 by 4. So it will be kq divided by 3 by 4. So it will be 4kq divided by 3. 4kq divided by 3. So here the question is asked in some weird way. So what is the value of k? It is basically 1 by 4 pi epsilon naught q, and divided by nothing else is required. Yeah, that's it. Q. 4 cancels. So I'm left with q divided by 3 pi epsilon naught. Q divided by 3 pi epsilon naught, because you can obviously see that this number 4 and 4 gets cancelled when you put k as 1 by 4 pi epsilon. So the number that will come over here, n, will be basically the number 3. That is the correct answer. Yes, perfectly fine. So this kind of question can definitely come in your JEE examination. Yeah, very good. So mathematics can be combined, guys. And in many of the entrance tests, be it IIT entrance, NEST exam, or UGEE exam, those research oriented exams, you will see usually maths they combine. Yeah, perfect. Now let's go to the next concept, which is the concept of electric field lines. The concept of electric field lines. Yes, we all know that magnets, you might have done this experiment in school. Magnets produce magnetic fields. Magnets produce magnetic fields around them. So it is very obvious that electrical charges around them will produce electrical fields around them. Electric fields around them. And what do any kind of field, be it gravitational field, electric field, magnetic field, generally give us? The fields, the field lines, they basically tell us qualitatively, qualitatively the strength of the field, but also they tell us about the direction of the lines of force, that act per unit charge. Basically the direction of the field. Force per charge is field. So what direction is the force going to act per unit charge? That's what they are going to tell me. And it also tells me how strong or weak the field is. It gives me a sense, an idea. And there can be beautiful fields drawn, and I can show it to you over here. Look at this. If I take a positive charge, can you see these arrow marks around? They are very bright at the center and they become faint because the field is very strong close to the charge, and it dies out when you go far away. And as you can see, the positive charge over here gives an outward electric field. Because if you stand here, if you take a positive test charge, the force will be here. If you stand here, a positive test charge will experience a force here. So anywhere around a positive charge, you will experience a radially outward electric field. But if I replace this with a negative charge, you can immediately see the electric field lines are inwards. Why? If you take a positive test charge here, that will immediately get attracted here. So the force will be this way. So field is also this way. If you stand here, the negative charge will pull this positive test charge. So that's why the field is in this direction. So anywhere around a negative charge, you will see the field will be attractive towards the positive test charges. That's why it is inwards radially. What happens if I move this charge here and there? You can see the field will keep on changing. As you take the charge here, this is more brighter because the field is strong here. If I take the charge here, this part becomes stronger. This is weaker field. If I add more charges, you can see the field strength increases. More region is covered. It's as if you have put a stronger bulb. Look at this comparison again. So earlier there was only a single charge. A very small region was covered. The intensity reduced after a certain point. But if you put more charges here, you can see the field has more range. It has increased. If I add even more charge, it will grow even further. I add even more charge, the field will become even stronger. It has more aura, plus 999. What if I put a negative charge in between here? Oh, beautifully, those field lines terminate on that negative charge. Can you see that? Yeah, these are all imaginary lines. Okay, it is not physical. Sir, can I see the electric field traveling in the sky? No, you cannot. These are imaginary. Hypothetical just gives you an idea. See how beautiful those electric field lines are converging here. But can you also see, because the negative charge is small in magnitude as compared to the positive charge, many lines are coming out from the positive, but not all of them are terminating on the negative charge. Some of them are going to infinity because this is a small negative charge. It's not very huge, correct? But what would happen if instead of a negative charge, I brought a positive charge here? Wow, this positive charge will also create an outward electric field. Both these electric field lines will come like this. Yeah, they will both come outwards. So this is how electric field lines play around with each other, guys. You can add a negative charge to see what happens over here. So again, this is how the electric field lines look like. You can create even more charges here. You can add some more charge here and see what exactly happens. Okay, so you can get a complex electric field. It's a complex electric field going from here and there and there and here. Beautiful, isn't it? Amazing. Loved it. This is how electric field lines act. So some of the important properties of electric field lines, let me just give it to you over here. First of all, due to a, yeah, this is very important. I'll just put it here. So the field lines originate from a positive charge, as you can see over here. So if there is a positive charge, the electric field lines will originate from it like this. But the same field lines, they will terminate on a negative charge, as I have shown you before. So if there's a negative charge, they will terminate. They will never terminate on a positive, and they can never originate from a negative charge. This is very important. So originate from positive, terminate on negative. This is one of the very important property. Then next important thing that you should know about electric field lines is that if you have an electric field line, if this is a field line, and you consider some random point over here, then if you draw a tangent to the field line at that point, this is the tangent which is drawn. The tangent in the direction of the field, because I can go like this also, I can go like this also. This is against the direction of the field, this is in the direction of the field. So if you move along the tangent in the direction of the field, that gives you the exact direction of the net field. So the field vector is along the tangent to the field line, is along the tangent to the electrical field line. This also means one more thing. If by chance this happened where two electric field lines intersect, if field lines ever intersected, then if they ever intersect with each other, then what would happen? That would be a miracle, because then there will be two tangents. And the moment you have two tangents, you have a new problem. You have two directions to choose. But that goes against our principle that the field direction is uniquely determined by the tangent. This is no longer unique. So now what will happen? There will be multiple tangents, and then I will say the direction of the field is ambiguous or unique, is not unique, is not unique, which can't happen. So hence this is not possible, not possible. Okay, what is not possible? Field lines never intersect. So that is the conclusion. Field lines will never intersect each other. That is the conclusion. Field lines will never ever intersect each other. Is this absolutely clear, my dear students? Yeah, you should always have a unique direction. Another important thing is that, I can put it here, if you have a small charge versus a large charge, let's say Q is more than Q, then you will see that from a smaller charge, let's say, Q charge is giving some lines, this big charge will give even more lines. Yes, more the charge, more the number of lines. So the number of field lines is directly proportional to the magnitude of the charge. More the charge, more the number of field lines that you should represent. It makes sense. Next important thing, if at all the field lines go like this, if these are your field lines, wherever they are congested, you would have seen that here also, the field is strong when they are close, but when you go far away, the field is weak. So that is another important thing which you should know. The field is going to be very strong when lines are dense, that means close to each other. But here the field is going to be weak when lines are far away from each other. This kind of field, where the field is sometimes strong, sometimes weak, this is also called as non-uniform field. The field is said to be non-uniform electric field. Can we have a uniform field? Obviously. So when you have a uniform field, what happens is that the field lines are equally spaced no matter where you go. They are equally spaced no matter where you go. So in such a case, you will see that the field strength, direction, everything is just a constant. It is uniform. They are equally spaced. This is uniform field. This is non-uniform field. Is this absolutely clear, everyone? So all these are important properties of electric fields. you should be able to draw any system and how their electric fields will look like. For example, let's just take, maybe you have a positive charge and another positive charge over here. So how will the electric field lines look like? Because they are both of the same amounts, uh, always field lines should originate. But think about it, when they originate like this, they will try to intersect, but they can't. So, they will just go like this. They'll just go like this. And you can see that there is a neutral point here. Yes, this is the point where electric field is zero, sometimes also referred to as the neutral point of that system. And if you show more electric field lines, it will look like this. This is how the electric field lines will look like. Similarly, what would happen if there was a positive charge and slightly more positive charge over here? Then this is how the field lines will look like. There will be few field lines only coming from this positive as compared to this guy. And the neutral point will shift maybe here. Maybe it will go like this. Not many field lines, but this guy will have many field lines. Many field lines because this is more positive. So more number of field lines will come from it. This is how it will look like. And the neutral point will be here, closer to this guy. This is where the net field will be zero. Makes sense because this is very small charge. This is very huge charge. So you'll stay far away from it to counterbalance the effect of the smaller charge. So you'll be closer to the smaller charge so that the effects get nullified. Similarly, if you have a positive charge and an equal amount of negative charge over here, how will it look like, the field lines? Positive and negative, guys. So it should start from positive and go at negative. So one line, so I can directly show it like this. It should terminate on negative. So another line, I can just show it like this, maybe. Then another line, I can just make it go like this and keep it symmetric on the top and at the bottom. Whatever you do on the top should be done at the bottom. Simple. Symmetry should be maintained. So this is how it will look like. Is that right, everyone? So this is how it will look like for a positive and a negative charge. You can show it for a positive and more negative charge also, or more positive charge and a small negative charge also. You can show it like that. So more lines will come from here, less lines will come out from there. So maybe a line going like this, a line going like this line obviously going like this. More lines will come from here. So maybe like this. Very few lines will terminate over here. Now the remaining lines will not have any space. So, they're just going to go out from here. Yeah, they're just going to go out from here like this. Yeah, something like this. This is what you are going to see. Okay, so this will also be something maybe like this. Once it comes, you will see a neutral point also. This will go like this. This will go like this. And you will probably see the neutral point somewhere over here. Yeah, this is where the neutral point will be, somewhere over here, where the net field will be zero. Because you can see very few field lines are there. Okay, that's how it will look like. So this is something which you should get used to, drawing the field lines. Okay, interesting, everyone? Loving it? Uh, can we find the field to the integration of rod and rotating it with d theta? If yes, how can we integrate? Adarsh Shodhya, that's a very good question which you asked. If you are trying to find the electric field due to a disk, okay, And when you have to find the electric field due to a disk, you usually take rings and you integrate those fields due to the rings, and then you try to find the field due to a disk. Correct. There is nothing wrong in that. But what can I do this, that I can take a rod and I can find the electric field due to a rod here, and then I take multiple rods like this. Is that your question? Multiple rods, I mean, you get the idea, right? It's like this, and then I try to find the electric field. This will not give you the answer. I'll tell you why. The problem is when you take rods, right? See, if you try to take rods like this, understand there will be some gap over here and there will be some overlapping over here. I mean, the charges at the center, you are counting it more than once. If you find the field due to a charge, you should not count the field due to it again. So, in the effort where you try to find the field due to the rod, and the next rod is immediately over here, next rod is immediately over here, next rod is immediately over here, are you seeing in this region, you are counting the charges again and again. So over counting will happen. Over counting will happen. So that is the reason why if you use a rod and rotate it, you will not be able to get the accurate field. It will be wrong. Is that okay? Absolutely clear? So that is not a correct way. All right, so let's see some of the questions on field lines. There is a long shell which carries positive and negative surfaces on the upper and the lower half. Upper half is positive, lower half is negative. How will the field lines look like? How will the field lines look like due to the positive and the negative half of the shells? Upper half is positive, lower half is negative. Come on, guys, not very difficult. Srilekha, see, most of the times you should go through the basics, most crude level. I mean, when you're talking about JEE physics, see, you should not be like, okay, formula, okay, I will be done. Spend quality time in understanding why, how, even one single line, do not accept it. All my students who got top ranks in JEE Advanced, not mains, I'm telling, JEE Advanced, because JEE Advanced is your ultimate level. They mastered a book. They solved those questions in the class and solved examples in the coaching modules again and again before grasping those concepts and moving to the PYQs of mains and then advanced. They questioned every single line. They tried to solve the question via different methods. They tried to ask, like exactly one student asked, I think others asked, can I integrate it like this? Can I integrate it like that? At least knowing why you should not integrate this way, why you should not go that way. Can I do FBD? Can I use energy principle? Why I can't use angular momentum? So these kind of things should come in your mind. And every step of problem, try to solve on your own, be it solved example or be it class problems after the class is over. And if you make a mistake, watch the solution, watch the video, but get a hang of it and again try to do it on your own. See if you're able to get that confidence. If you're able to explain the problem to your brother, sister, or to your junior or your batchmate, only then you have understood. Think of explaining the same problem to someone else. Are you able to convince, not just explain, blah, 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 convince the other person why the solution is correct? Are you able to do that? Then you have understood and solved physics. Then you can get good marks. Is that clear? Yeah. Solving exercise 3 of Tattva will not be, I mean, it's not enough for mains, it's more than mains because level 3 of Tattva is higher than mains and closer to JEE Advanced. But yes, if you have done exercise 1 and 2, only then go for 3. If you have not done 1 and 2, please don't go for 3. First, complete 1 and 2. Solve the PYQs, solve some more random questions, maybe HC Verma, DC Pandey, or whatever pedagogy app is there. I'm guessing you are a pro student. So just solve that. Okay. Then go to 3. Okay. Yes. Even if you're in 11th standard, this is the kind of thinking, Srilekha, you will be needing. Okay. Right from the beginning. You cannot do it at the end. So 4 months are remaining, sir. Can I study physics and complete the syllabus? See, if you want to complete, I can complete the physics in 6 hours or 7 hours. My formula video is there. 7 hours. Complete syllabus. That is also completing. But is that really completing physics? No. You have to understand why, how to use the formula, when not to use this. So think, even when you're using a formula, why am I using this? I know another formula. When to use that? Why not use this? Suddenly, one formula will not be used. A range formula will not be used. Sir, why sir range is not used now? Why am I using kinematic equation? Why is it simpler like this? What will be the problem if I do it like that? Try and doing it. Maybe you will get stuck. Then you will realize, oh, this is why I should not do it. So this is the level of thinking which is needed, guys. Okay, great. So what about this question, my dear students? Which of the following statements about the field lines is incorrect? Electric field lines never cross each other at every point. This is 100% correct. Electric field lines do not form closed loops. See, first one was about intersection. This will not happen. They never cross each other. Perfectly fine. They do not form loops. That means like this. They don't form loops. That is absolutely correct. Electric field lines cannot be taken as continuous curves. They have to be continuous. I mean, like this. How can it be discontinuous like this? This is discontinuous. So they cannot be taken as continuous curves is wrong. Electric field lines start from a positive charge and they end on a negative charge. So this is also correct. So ABD is correct. So C is wrong. Yes, C is the wrong one. Yes, Vasuki, perfecto. Awesome. All right. Next one. Three charged particles are shown. Which particle has highest charge to mass ratio? Which particle has highest charge to mass ratio? I have an idea over here. I just told you acceleration is force by mass, which is QE by M. So Q by M is charge by mass ratio, and this is E. So I can see that Q by M is directly proportional to the acceleration. So who got accelerated a lot? This is a small acceleration deviation, small deviation. This is a large deviation, large change in the path. That means there is more acceleration over here. So if the acceleration is higher, charge by mass ratio is also higher. That means it should be C option. That means it should be C option. Is this clear? Okay. Waves is going to take a lot of time. I mean, if you're talking about light waves, it will start after electromagnetic waves or somewhere around that part. Okay. So after magnetism and all of that, if you're talking about waves of 11th standard, that's one of the last topics. It will probably come to September or October. Okay. Hi, Harsha. Good evening. Good evening. Yes. So that was the last question. So the homework question has already been given. Let me show it to you again in case you have missed it. Where did that homework question go, man? Yes, this was your homework question. So due to a ring at this distance, what is the electric field going to be? That was your question. Please put the question's answer in the comment section. Okay. So that was the end of the class. We have done electric field due to rings, arcs, point charges, and the field lines concept, along with the force due to the field. There is a separate lecture on Gauss law and flux, then a separate lecture on the applications, let's say on the shells, spheres, and line charges, and so on and so forth, and sheets, everything. And then a separate lecture on dipoles. So that is how we are going to proceed. Is that okay? Cool. All the best, my dear students. Have a great time. See you very soon in the next class. Okay, 8 o'clock, 12th standard, 11th standard at 6 o'clock. Bye bye. Do not forget to like this video. Many of you forget. That's your Guru Dakshina. Do that. Okay. Bye bye.